All right, so in this video, we're going to go over, I'm just going to try to one-shot or at least get an MVP going for just a simple wood beam design using ASD. So right now on my screen, I have Beam Design Chapter 6 from the Breyer Wood book. And so we're going to try to feed this context to AI. It's already, AI is already trained on a lot of general information, but we're gonna see how it goes. So I work out of VS Code, so it's Visual Studio Code, right? So you can just start that up, and then typically you want to start a new folder, right? So open a folder. I already have one going. It's called my school community here. So I'm going to start this up, and you want to work out of a folder with your projects, right? And put all your context in that project. This is the welcome screen, and then how I start is I just start up a new terminal. Can go in here, 3 columns, and then we create multiple terminals here if we need 3. All right. So I already have a Claude MD for global, which has a lot of my rules in it. And then there's also a local Claude MD in this folder. It's on my school community. You can take a look at those. But then, we're just gonna get this going. I'm gonna try to create kind of like an online MVP similar to the Forte design software. We're just going to start simple right now and just do like a simple wood beam design, right? So once you have your folder, you can either type Claude, and then you can set the permissions. Right, so Claude, it's wanting to do the permissions I already do. Which is Claude, dangerously skip permissions. So you can do that if you want. Then it has access to your whole computer, or you can just hit Claude, and then you can do Shift Tab for your different modes. Auto mode right now is a pretty good mode. So let's do the auto mode. I'm gonna hit yes, and actually we're gonna do a plan first. So I'm using Visual Code Studio. I'm gonna say I want to create an MVP for a simple wood beam design. This wood software will be, um, the inputs will be the span, there'll be the loading, and it's going to be only for dimensional lumber right now. And we want to do it based upon the IBC 2024. So we need to use the latest ASD codes. Okay, and so it puts that in there, right? And then we want to start planning first. I'm going to do plan mode, and let's think what else we want to give it. Typically, I want to try to give it like some sort of a definition of done, right? So I'm going to say we want to, for our definition of done, we want to mock up a local website right now, just a local host, and we're gonna just go through a simple beam design to test it out. I'm gonna give you context for chapter 6 of Breyer's design book. It's located in the knowledge folder in this folder. Use that to check your designs, and then run some reports and give me feedback if they're passing. And so it should be able to pick this up. This is speech to text, and sometimes it doesn't pick up things correctly. But if you go, here's my folder. I put this right here in this folder, and so it should be able to find it. And I'll also go something like this, click in there, Control C, and I can go Control V. This is where the book is located. this is where the book is located. Oh, you see it already found it, right? So it's gonna start cooking. So we're just gonna let it cook here, and you see I shift tabbed it into plan mode, and this little bar down here, it's showing the context, how much is taken up here. Ideally, Claude will auto compact for you once context gets high. I typically, I've watched a good amount of tutorials on this, and a few of them by the Anthropic guys, and they talk about how AI starts getting dumb. It starts getting context rot after like a 40 to 50%. That's not to say you can go you don't go past it all the time, but it's just something they've noticed. So I try to keep that bar low as possible. Yeah. So it's still cooking here. I want to just explain kind of what we're doing. Um, so AI is going out and trying to, let's just put this up here. It's trying to figure out the best path forward, right? So we're over here in New York, say, right, and we want to get over to Europe, and so it's basically, we told it this is our destination with some words, basically, that and this is in our mind, and the AI is going to need to be able to extrapolate in between here, right, in order to get us to there. And what happens a lot with this AI, right, is we have to steer it because it's not a straight path. This filling in this void here is really, really, really vague for the AI. And so what you'll find is it's gonna go to here, and then it's gonna veer off, right? And so if you keep going, letting it go, it's gonna get to this point, and it's not gonna be our destination point, right? And so in reality, you really have to kind of steer it, do a corrective prompt here, and then it's going to go back here, and then you do a corrective prompt here, right, to get to this endpoint. And so that's what you'll find here, and that's why there's this plan mode, because you need to be able to easily define what the end goal for it is, and it needs to be able to interpret it. But yeah, that's kind of what's going on. And you'll see that it's searching here, it's doing some insights. This is based upon its training data, so it's pulling from there. We really didn't give it any sort of UI descriptions or UI role, so it's going to try to interpret that based upon skills that it has, right? So we've got a whole bunch of skills in here. Let's see, one of them is the front end design tool right here. So it's a GitHub repo that goes over front end design skills. It's a pretty old repo. What else is in here? Yeah, as you can see, there's a whole bunch of / commands in here that we have access to. All right, so we just got done with planning mode. That took a few minutes. And so now it's got some questions for me. And we're going to go through this. How wide should the species grade scope be for V0, right? So version 0. Matches Breyer example exactly. Smallest verification surface. You only sign off on one row of the NDS supplement. Fastest path for working localhost. Add grades. Yeah, let's do that. Let's do one. Let's just do a simple one. And we can add these if you want. One of the things I've learned here is, it's very exciting here, but I don't try to chunk off too much, because it's going to create a whole bunch of code, and it's going to be unorganized code, and then you're going to have to go through. Here's the thing here. The code is pretty cheap. It's the verification on your end to go through it, which is really expensive, right? And so let's get the fundamentals going. Let's get things working, and then go from there. So I'm just going to hit 1, and then C the C sub L factor, right? How should we handle the MVP that is not fully lateral brace? Yeah, so let's just do that. Okay, and let's submit it. Let's let it cook here. So the plan's confirmed, and now it's going to write the final plan for us. All right, so the plan is done here, and here is the plan after it asks me some questions. So we're going to start at the top here. It's the name of the plan. I'm just going to scan through it here. Yep, the intent is to prove the workflow on a single known good case for expanding scope. Verification target is Breyer designer with structures, example 6.8, chapter 6. Every reported number from that work must be produced within 1%. If it doesn't, spec it's closed. This is the first structural calc, right? MVP scope locked. Simple supports band, uniform loads, sawn dimensional lumber, 2x4 through 2x12. Okay. Right, so it's going to create these files, existing patterns, to modify these files. Some data classes, is going to create some databases. These are all local for now. Here's some things it's proposing, and some designs it's kind of proposing. This is verification, implementation order, spec. So it's going to do all of this. You know, it's pulling this from my Claude MD files. Per Joel's requests, here's that. All right, so that's it. So let's scroll down to the bottom here. I'm gonna do, you know, if you want to refine this plan any more, you can go to UltraPlan Claude Code. I'm gonna just do a different video with that. But basically, this is a single agent use here, or single agent harness here locally, and then when it pushes to the cloud, it uses multi-agent harnesses, and it goes through a whole bunch of different or additional steps, right? I haven't really seen too many differences between the plans, but yeah, it's the UltraPlan online supposed to be better, and you can do it online and then start it here in the local. So I'm gonna just hit 1, and it's gonna start cooking. And you'll see this context window, this is getting kind of tight here. I just started a build. I'm not gonna stop in the middle of it, so we'll see what happens. It used a lot of its thinking power in this plan, so that was good. And now it's going to start building, and the context is going to start growing. But we'll see where it gets. So I like watching these little insights that pop up. So and then reading them. So watching along here, right? So it says I traced the Breyer 6.18 math end-to-end and caught a subtle thing. Textbook does an iterative trial. First assumes C of 1.2 given FP for sizing, picks 2x6, then re-verifies the actual CF 1.3 given. The fixture only needs to match the final numbers because that's verification gate. Our engine will compute CF directly from chosen section. So there's no trial iteration in code. M in Breyer's reported is 12,390, but that's in inch pounds, not foot pounds. The agent's earlier extraction had a units typo, so it caught something. I verified with total. With W total, so W all squared over 8 is equal to 45.3 times 13.5 divided by 8, right? So it's doing the math here, getting this wrong by 12x, exactly the kind of silent bug the fix will catch, right? So it's a unit issue. For deflection, W must be in, so it's doing a unit verification here, which is good. So now it's writing out the code in the docs for it. You know, and it's pulling from online here all these numbers, right? So just locally available NDS. So it's asking me to verify these numbers to make sure it pulled them correctly from the tables. One of the things I've noticed with these AIs and the engineering tables is there's a lot of drift. It's going to drift in the tables, and it's going to pull the wrong numbers a lot of times. So that's something I've been working on. I've been creating some skills around that and teaching it visual verification using Gemini and Claude Vision. And right now, ChatGPT, the image generator 2.0 just came out. And so that's supposed to be a way better one. So I'm going to switch on to that and see if that does better. But that's one of the main things. That's what's pulling this dual verify sort of thing up. All right, so this is the example they're talking about. Example 6.18 on beam design using ASD. So we're gonna go through. We're gonna hopefully create this with Claude Code and see how it does. All right, so let's go back to it. It's saying there's some errors it found, and a few things that it's updating there. Okay, we're gonna just keep it cooking. So you can see here, there's another insight. It's looking like it's got some passing values. They're within plus or minus 1%. On first try, no iterations. It's rare for engineering code. It usually takes 2 or 3 iterations to find unit conversion bugs. The reason this worked, the spec-first discipline forced me to lock both units and expected outputs in JSON before writing the engine code, so the engine was built backward from the target. This is exactly what ClaudeMD calls verification before claiming done. Okay, so it's pulling from my ClaudeMD file. It's saying that. I don't know if that's totally what I meant. And then it's got 20 tests. All right, and so now it's wiring up the Flask UI, which is the user interface it's chosen to make this. And then you can see down here, look at my context here, it's starting to get killed. It's gonna auto compact here. So it's in execution mode, which is fine. Hopefully it's not making any dumb mistakes. Yeah, we're gonna have to do an auto compact here and then redo it basically, or it's gonna auto compact, clear the context, and then keep working on it basically. So right now you see it's compacting the information right here, and it's gonna do a summary with the auto compact. It does a summary so that you don't lose context on this whole chat, right? So this whole chat is a window that fills up, and so basically, let's get rid of this stuff here. This is your context window, and we're chatting in here, and we're filling it all up. And when it gets to this point, the 84% here, it's going to start compacting. So then that compacts all of our context down. It's going to compact down to, I don't know, you'll see it pop up, and then now this is our new context window. So this whole space. You want a lot of space for the AI to think. Otherwise, it starts getting context anxiety, context rot, all of those sort of things that make it act stupid, essentially. So we're back down at 36%. This bar here, I've noticed that once it compacts, it's not entirely true. All right, so we got look at that. We got our first UI that just popped up. This is it's on a local port, right? And it's just hosted locally. It's not online. You can get it online if you want. So let's see what we got here. All green, opening the UI, delivering the final status report. Looks like it's doing some things. All right, so it's gone through and done some tests here. All right, so let's open this up. We're gonna pull up Breyer. You know, it said it already tested this for us. And this is the part where once you start unlocking skills and playwright, it's another essentially add-in or repo that you can install that can then go ahead and test these for you. I'm just going to test this in person right now. So let's see here. What are the inputs here? So span is 13. Spacing is 16 inches on center. Yeah, so it's saying for deflection, we got that. Okay. So it's saying that. And then, so how do you click that? You can click these buttons. Look at that. So, you know, those are, right? So those numbers change. Look, that's a count. That's a changing, that's a changing number here. So let's do that. Oh, and look, in our automatically add an auto sizer too. So it's saying it should be a 2x8. So that's pretty cool. Right, so is this example here? So let's see, 2x6 dimensional lumber. All right, so it's actually saying here. It's actually saying here that since the deflection criteria is not met, a higher grade or section should be used in this example. The next higher grade of no more is better with E to meet the deflection criteria that is allow. Okay, so all right, so you know we change it to we did the auto. Let's see, we did the auto size here, right? And auto size says it needs to be 2x8. The example is not very clear here. At the bottom, it says, hey, it says the deflection doesn't work, but we need a higher grade. We did a DF number 1. And they're just like by inspection, this works. Like they didn't check it, they didn't do any calcs. This is from the Breyer's book. But you know the elasticity, the modulus elasticity here for the number 1 better DFL is the 1800, right? Or you know 1.8 million psi. So the AI Claude kind of skipped over that, didn't even catch that, and so it's doing an auto size based upon the section properties and not the modulus of elasticity, right? So I'm going to, so now this is a loop. So with the AI, you've got to start looping on it and making sure you get the right results, right? So I went to NDS's website, right, and there's the free resources. You can open this up. I went here just to verify, right? in the Douglas fir larch here. You can see, so number one, sorry, this is blurry. This is just the free version online. AWC makes it available. But let's see here. I do screenshots like this, so I can do a screenshot and let's see, let's scroll up a little more. Maybe AI I'll be able to pull it from another resource. Maybe Claude will be able to pull it from another resource. Let's do that. I'm going to screenshot that. And then I'm going to circle. I'm going to circle this. Circle these. Right, circle that. And then I'm going to feed it back. Feed it back. I'm going to say, so the example in Breyer, the deflection did not pass, and so now at the end of the example, it said, hey, change this to just Doug fir number one or better, and the modulus of elasticity will change, and then that will fix the deflection issue, and they don't just go and calculate it. So you missed that. So here's a screenshot of the table that you need to, pull the modulus of elasticity from based upon the grade. Maybe add into the tool the different grades also, so we can toggle that, right? And let me know if you have any questions. So I'm going to do Alt-V. That pastes the image in the chat, and then I'm going to hit enter. All right, so we're still cooking through this. As you can see, it's going back and changing some of the code, making some additions, subtractions. That's what the red means here. It's a subtraction. There's the addition here. All right, so Claude went back and checked based upon, number one or better with the modulus of elasticity, 1.8 KSI, or I'm sorry, 1800 KSI, and it's saying that it doesn't pass. Like, let's see, look at this ratio here. So Breyer just basically winged it, didn't do the calcs, and said it passed where the ratio is a 1.0 ratio. So like, I wouldn't do this in practice, just FYI guys. That's like, I would keep the ratio lower, maybe a 0.9 or something. And the other thing that's not really feasible here is you would actually, instead of like alternating the grades and bumping things up, you would just bump the size up, because that's a cheaper option than doing like a special order number one or better grade 2x6, right? So depending on the area, you're not going to have that stuff available. So it's going to be special order, and contractors are going to hate you for it. So like another example why these books that are written by people who don't actually practice could cause problems. And so I want to point out something here. So just what I was just talking about is Claude Code now just use that feedback I gave it about upsizing the grade, right? Like Breyer did it, and it's thinking that this is the right way. But I was just talking to you about, I was just talking into this video about this, where it's actually not the right thing. So I'm gonna copy this, and like this is not we're steering this little ship, on bigger projects, like a tanker that you're just trying to steer across the ocean. But I'm gonna do this. I'm gonna select that, Control C. I'm gonna say that this is actually not what we want to do. We want the auto sizer to go ahead and default to upgrading the size of the member instead of upgrading the grade. So that's the first thing that should check. And then if when you get to like a 2x12, it doesn't work, then you upsize the grade and go to the higher grade. And then I'm going to do Control V. So I'm gonna try to course correct it here. It's, as you can see, the context is kind of high. We're at 83%, and so it's going to have to do a self compact here. So it's course correcting here, and it's doing some code deletions, right? And so it's rewriting some of these rules in the comments in here, right? So and now it's going to run some final tests. And we're at a 50% context on this. We're using Opus 4.7 in auto mode. All right, we have the second version here. It's created. Here's the summary. Let's open that up again. I'm going to close these actually so we can read that better. Right, so it's looked like it's done. It's verified the old behavior, new behavior. It did an additional test case here. All right, so there it is. It's added the grades. If we go here, check section, it's going to say failure here, right? Because of the demand here. So that's that's the check that Breyer has said that was good. Let's see what else here. If we change some of these toggles, see if anything changed, right? Those seem to be changing. All right, so that's just the start of it, right? You know, the powerful thing about this is, you know, we can tweak the formulas here. So let me give it this. Let me give it this prompt. Okay, let's change the formulas up. Let's do a K-LaTeX formula so that all the coded formulas look a lot better. And then also add a diagram at the top of this page, you know, to show the beam span, the support conditions at the end of the beam, show the loading on it, and then label the beam with the beam size also. I'm going to do a screenshot of this. Get my get my crosshairs out of there. We want a diagram similar to this that shows the loading, the beam, and then also add a diagram for the bending moment and shear diagram, kind of like this image. My thing cuts off, Alt V, post the image in there. All right, and then let it cook. I'd probably, yeah, that's fine. Sometimes you want to switch to plan mode, but for this scenario, let's just let it keep working on this. All right, so it's going through the checklist here. It's going to add the KTeX rendering for factor chains, which is the formulas. It's going to change those into like LaTeX formulas so they look a little more visually appealing, kind of like what RESA calculate connection does. And then it's going to build the SVG diagrams, build a shear moment diagram, and then verify everything in the browser. All right, so here it is. It just finished up. And here's, you have us a summary, and then here's, you know, here's what it basically came up with. You know, this is just one-shotting it with these diagrams and everything. Obviously, there's improvements I can make here. I could do these collapsible. You need the print button. Now you Now you need some sort of project management setup, right? I would probably go towards, yeah. So, well, yeah. I mean, I could talk about that forever, but basically, this is just the base module for beam calculations. You can have a whole bunch of stuff, but so you can check the section and let's go through here and check that. LNS 2x6. Number one, that doesn't work. Here's the line load. Change those. Auto size 2 by 10. See that the formulas got updated here, and they turned it into kind of a LaTeX format. But anyways, yeah, that was it.